Now, don't get all upset, but the moon is shrinking and getting wrinkled, pretty much like a grape turning into a raisin. That happens because our natural satellite has been retaining its inner heat for over 4 billion years, but its core is gradually cooling down and becoming more dense, like me. Unlike a grape's flexible skin, the moon's surface is pretty brittle. This brittleness causes faults to form where different sections of the crust push up against each other, leading to what scientists call moonquakes. So far, our satellite has shrunk by around 150 feet in circumference. It's such a tiny change that it won't affect the look of eclipses or the phases of the moon. Even tidal cycles won't be affected since the moon's mass hasn't really changed. The shrinking process won't directly affect us down here, but that doesn't mean that all humans are safe. Moonquakes, caused by the shrinking process, have been a concern for years. During the famous Apollo missions, NASA astronauts left seismometers at different points on the moon. Those are devices capable of identifying seismic activity on the lunar surface with exceptional precision. The equipment was operational for several years, and it managed to capture over 12,000 moonquakes, ranging in magnitudes from 2 to 5. Up until 1977, the team was able to identify 4 distinct types of quakes. Some tremors, like those caused by meteorite impacts, were relatively easy to identify. But the cause of the so-called shallow moonquakes remains a mystery to scientists, and that can be an obstacle to future missions on lunar soil. As the name suggests, shallow moonquakes occur relatively close to the surface, typically between 30 to 135 miles beneath the surface. Recent research suggests that these tremors are triggered by the compression of the moon's surface, leading to the formation of thrust faults, where one surface layer is pushed up over another. This study also discovered where the epicenters of the strongest ones were. It all started in the South Pole region, precisely where we want to settle down. Interest in the lunar South Pole peaked in 2023, when India's Chandrayaan mission successfully landed and deployed a rover to explore the area. NASA also has plans for the same spot. And their ambitious goal is to take astronauts there for the very first time. The Artemis 3 mission, scheduled for 2026, currently has 13 potential landing spots at the South Pole, represented by the blue squares here. One of the options is situated within a geological feature called the Gerlach Rim 2, which is a strategic area for exploration. It might have ice, because parts of it are completely in the dark, but it's close enough to areas that do have sunlight, which is crucial as a source of power. Now, take a look at the pink dots on that same map. They represent possible epicenters of the strongest moonquakes recorded by the Apollo missions. That means that thrust faults in the area could be relatively young and potentially active, representing a real danger to the Artemis 3 crew. These astronauts will journey to lunar orbit over the course of 30 days, and 2 crew members will descend to the surface, spending about a week at the South Pole. Their moonwalk will be particularly challenging, given the extreme temperatures of these permanently shadowed regions. The presence of moonquakes and possible landslides only adds more danger to this mission, as this phenomenon is far more frightening than earthquakes. The strongest moonquake ever recorded had a magnitude of 5.7. You might think that's not a big deal, considering that countries like Chile, Colombia, and Papua New Guinea experienced earthquakes of similar magnitude in 2023 without significant damage. But the gravitational pull on the moon is relatively weaker than on Earth, so what feels like a gentle tremor on our planet might be a real ground-shaking event up there. This happens because you're not as firmly connected to the surface of the moon as you are on Earth, meaning that seismic waves can cause the surface to move more freely. There's also a huge difference in duration. Earthquakes typically last between 10 and 30 seconds, with some lasting up to 2 minutes. A moonquake can persist much longer than that. Our satellite is essentially a solid, rigid, and dry sphere. So, when a tremor shakes the moon's surface, it resonates powerfully without any natural means of dissipation. Moonquakes can last for a good 10 minutes or even longer, with little tremors sticking around for hours afterwards. Now, these new findings about shallow moonquakes won't actually change the potential landing sites for Artemis 3, and they won't affect the duration of the mission either. That's because accurately estimating how often a specific region experiences these tremors is tricky and unpredictable. What scientists do know is that these shallow quakes aren't very common and pose a low risk to short-term missions on the lunar surface. But that situation changes completely if we consider long-term habitation on the Moon, and that could happen sooner than we expect. The Artemis 3 mission represents an important first step towards space colonization. China is also making the first moves to establish a permanent lunar base at the South Pole by 2040. Their strategy involves utilizing 3D printing and brick production from lunar soil for constructing the moon base. That definitely sounds fascinating, but putting together a setup like that comes with a bunch of challenges, including dealing with intense cosmic radiation, the lack of water, and of course, long-lasting moonquakes. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed, so when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Far-Side Seismic Sweep mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. Well, that makes me breathe easier. How about you?
What if we lived in a world where the Moon and the Sun swapped places? Yeah, I know what you're thinking. The consequences would be staggering and catastrophic. But here's an interesting take. What if we somehow survived all this? What would our life look like in such a new world? And what would happen to the solar system? Time to find out. Let's start with the Moon. Did you know that the Moon is responsible for the tides on Earth? You know, that thing where the ocean goes in and out like it's playing a game of beach volleyball? All thanks to our satellite's gravitational pull. The Moon also helps stabilize Earth's rotation. It's pretty important if you don't want to end up like a certain planet that spins on its side. Looking at you, Uranus. Plus, it acts as a shield, protecting us from some of the more harmful cosmic rays, asteroids, and space debris. It's like our personal bodyguard. And without our satellite, we might not be here cracking jokes and enjoying life at all. Some scientists think that the moon played a crucial role in the development of life on Earth. Without its gravitational pull, we could have a crazily erratic climate. Also, the moon could have redistributed water across our planet, and we all know that water means life. As for the sun, we all know how important it is. It provides light, heat, and energy for all the planets. But, just like any good party host, the sun can get sometimes a little too intense. Never forget that it's an extremely powerful and massive star, with a surface temperature of about 10,000 degrees Fahrenheit. If it wasn't for our ozone layer, we would all get burned instantly. The distance between the Earth and the Sun is about 93 million miles. Scientists took this distance and turned it into a unit of measurement, 1 astronomical unit, or AU. The closest distance that the Earth could approach the Sun without being completely destroyed is about 0.9 AU. At the same time, if we move too far, further than about 1.2 AU, our planet will turn into a snowball. So, we got pretty lucky with our location. Meanwhile, the distance between Earth and the Moon is about 0.002 AU, or 240,000 miles. It's super close to us. Now that we know how important these two are, and how much their position affects our world, let's try to swap them. Surely nothing bad will come of it. First, let's imagine for a moment that the sun was in the moon's place. You probably already know what will happen to us. The intense heat and radiation from the sun would be like the world's worst sauna, with the temperature on Earth rising rapidly. Any living thing on Earth would leave behind nothing but a pile of ashes. But the destruction wouldn't stop there. The atmosphere and oceans would be stripped away by the solar wind, leaving the planet exposed and vulnerable to the radiation and particles coming from the sun. It would be like a giant space hairdryer on full blast, with Earth's atmosphere and oceans being blown away instantly. Forget about melting ice caps. The entire planet would be one big puddle. But that was a scientifically accurate answer. Boo, boring. Now, what if we could somehow survive this catastrophe? Like, what if we had some super advanced technology to protect us from being fried to a crisp? First up, even if our planet somehow survived, things would still get pretty toasty, since the sun would still emit way more heat and energy than the moon. Also, unlike the moon, which goes through periods of darkness during its lunar night, the sun has a constant energy source through nuclear fusion. So at least we wouldn't have to worry about freezing every night. We'd just be sweating buckets in our sleep. Of course, all this extra heat would have some serious effects on our ecosystems. Plants and animals would have to adapt to survive. And we might see some major changes in the way life on Earth operates. Imagine the confusion of nocturnal animals. Without the moon, they would have no idea how to navigate or hunt. So, what would we do in this new, super hot world? Well, maybe we could build some seriously high-tech greenhouses to trap all this heat. Or we could use some giant mirrors or other reflective surfaces to manipulate the amount of sunlight that Earth receives. Next, we have the sun's gravity. Remember how we said that the moon's gravitational pull is just right for stabilizing Earth's orbit? So, if we replace it with an entire star, things would get pretty wacky. We're talking about extreme changes in seasons, climate, and all sorts of weather-related shenanigans. Your everyday life would look like it's trying to do the cha-cha slide during an earthquake. The Earth's rotation would also speed up drastically. This means shorter days, longer nights, and lots of confusion with working hours and birthdays. So, is there any way to fix this? Well, hypothetically, we could use some massive spacecraft or other technologies to artificially adjust Earth's orbit and rotation. For example, we could launch rockets or space tugs that would slowly push our planet into a new orbit that's more stable and consistent. And that's not all. All this gravity play would also mean new tidal waves of epic proportions. We're talking waves so high that surfers would need oxygen tanks just to catch a ride. Imagine trying to sail a boat through a hurricane while riding a bucking bronco. Yeah, yeehaw! The moon also mixes up nutrients in the ocean and helps support marine life. So if we swap the sun for the moon, those nutrient-rich waters would be a thing of the past. The ocean would become a stagnant, lifeless soup, with nothing but algae and plankton to keep us company. We'd have to resort to eating seaweed sandwiches and drinking desalinated water just to survive. And let's be real, nobody wants to live in a world without sushi. So what do? Well, we could try to somehow artificially create tides or mimic the moon's gravitational pull on the ocean. Like using pumps or other mechanisms to move large volumes of water around in a way that creates a similar tidal effect. Or we could try to help marine life to adapt to the new, less nutrient-rich ocean. Maybe developing fish farming or aquaculture. Finally, don't forget about radiation. The sun is basically a radiation factory. It could seriously mess with our health and electronic devices. You think your phone is fragile now? Imagine what would happen with it under a giant solar flare. So we'd need some seriously advanced shielding technology to protect us. We're talking materials that can withstand temperatures hotter than a jalapeno's backside, and magnetic fields powerful enough to deflect charged particles. Oh, and tons of sunscreen. In summary, if we replace the moon with the sun and somehow manage to avoid catastrophic consequences, it would be a completely different world than what we know. But it wouldn't just be the Earth that would feel these effects. So what would happen to the rest of our solar system? For starters, if the sun, with its crazy gravitational pull, took the moon's place, it would start seriously messing with the other planets' orbits. They might be sent careening off in random directions, like bumper cars. The planets would also have some taste of the sun's fiery personality. They would have to deal with all the radiation and charged particles. Lastly, the sun's magnetic field is incredibly strong, and if it took the moon's place, the other planets would be forced to dance to its tune. This could cause electrical storms, auroras, and other crazy electrical effects everywhere. And what would happen to the moon itself? Unfortunately, its reign in the center of our solar system won't last too long. Most likely, it will either start orbiting the sun and be eaten by it, or simply fly away like a free birdie. So there you have it, a cosmic prank gone horribly wrong. What can we say? Let's just be thankful that such a scenario isn't physically possible, and instead enjoy the beautiful moon and the life-giving sun from a safe and comfortable distance.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this. How did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The Moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the Moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the Moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several 100 million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
There are a few theories about how the moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, there's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about 1/3 of a ton of rock and soil from our satellite. These samples showed that Earth and the Moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the Moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the Moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the Moon would be the same as on Earth. But they are a bit different. The Moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the Moon's formation these days is the giant impact model. Meteorites coming from the Moon are a great source of data for studying the origins of our satellite too. They can tell us even more about the Moon than Apollo samples, all because such meteorites come from all over the surface of the Moon. Meanwhile, Apollo samples were collected just in one place near the equator, on the near side of the Moon. On a starry night, you look at the sky and see twin moons high above Earth. It's a view science fiction fans can only hope for, but it could have been a reality billions of years ago. If we want to be super precise, 4 billion years ago. A recent model suggests that the highlands of the Moon's far side could have been created by a collision with a smaller companion moon in an event dubbed the Big Splat. The mystery of why the near and far sides of the Moon are so different have been puzzling astronomers for decades. The near side of our natural satellite is low and flat, while the landscapes of the far side are high and mountainous. That part also has a much thicker crust. It leaves us with a somewhat lopsided moon. According to the giant impact model of the origin of our satellite, a Mars-sized object crashed into young Earth early in the history of the solar system. This event produced loads of debris that then coalesced and formed the Moon. The new model, though, suggests that there could be a second moon orbiting around Earth. It would have been around 750 miles in diameter and could have formed in the same collision. Later on, this smaller moon could have fallen onto the bigger one, coating one of its sides with an extra layer of solid crust tens of miles thick. This model fits the moon-forming giant impact theory surprisingly well. After all, it does predict that there had to be tons of debris left in orbit around Earth after the collision, besides the Moon itself. It also agrees with what we know about the dynamical stability of such a system, the ages of lunar rocks, and the timing of the cooling of the Moon. There are other computer models that suggest a companion moon too. Another team of scientists used computer simulations to figure out the dynamics of the collision between the Moon and a potential smaller companion. According to their model, it was about 1/30th the mass of the main Moon. They tracked the distribution of lunar material in the aftermath of this event and its evolution. They found out that the impact would have been relatively slow, at a mere 5,000 miles per hour, which is slow enough for rocks not to melt. Plus, no impact crater would have formed at such a speed. Instead, the crust and rocks from the smaller moon would have spread over and around the bigger moon. On the other hand, such a collision sounds a bit weird. Being slow, it doesn't leave an impact crater. But at the same time, it splats material onto one side of the bigger object. There is a theory that the companion moon was originally trapped at gravitationally stable Trojan points, sharing the moon's orbit. But later, it became destabilized after the moon's orbit moved further away from Earth. The collisions could have happened anywhere on the moon, but that might be the reason why today's moon is lopsided. This model also explains the differences in the composition of the moon's crust. On the near side, it contains more potassium, rare earth elements, and phosphorus. These elements are thought to have been concentrated in the magma ocean that remained under the solidified crust of the moon. In the simulations, the collision squished this layer onto the near side of the moon. But even though this model explains a lot of things and answers loads of questions, the theory remains unconfirmed. We still don't know the full history of the moon and what really happened there. Scientists say that the best way to figure it out is to get more data from lunar orbiting spacecraft. An even better way to get information would be a human mission to study the moon.
Hi everyone! Today we'll be talking about the controversial music that astronauts once heard in space. A few years ago, NASA made public the recording of a bizarre music that the astronomers from Apollo 10 reported hearing in May 1969, while they were flying over the far side of the moon. At that moment, they were out of radio contact with Earth. This happened months before the first astronaut set foot on the lunar surface. There were 3 people on board: Thomas Stafford, John Young, and Eugene Cernan. The sounds lasted for about an hour. Astronomers managed to record them and transmit them to Mission Control in Houston. Now, I want you to listen to these whistling sounds.
That music even sounds outer spacey, doesn't it? You hear that? That whistling sound? Yeah.
Don't they resemble some kind of otherworldly outer space music? So the question is, could the astronauts have heard alien music coming from outer space? Well, there's another more simple, non-alien involving explanation for this cosmic phenomenon, but we'll talk about it a bit later. In the audio recording from the Apollo 10 mission, astronaut Eugene Cernan, who was piloting the lunar module, could be heard asking John Young, piloting the command module, if he could hear that whistling sound. Cernan was the first one to call these sounds music and to add that they were kinda outer spacey. Later, when the 2 astronauts asked Tom Stafford, who was in the lunar module with Cernan, if he could hear the sounds too, he confirmed it and stated that they were really weird. Young suggested they should find out more about them. Nobody will believe us, he added. Apollo 10 was a mission that paved the way for Apollo 11, which landed 2 humans on the lunar surface. The Apollo 10 astronauts flew to the moon in a command module. However, 2 of the crew members also had a ride in the lunar module, which allowed them to drop down to less than 10 miles above the moon's surface. So, since they managed to approach our natural satellite so closely, could they have heard something coming from the lunar surface? Well, apparently not. Turns out that the creepy whistling sound was nothing more than some interference between the VHF radios on the 2 different vehicles. Interestingly enough, Apollo 11 astronaut Michael Collins later wrote in his book, Carrying the Fire, that NASA technicians had warned him about the whistling. He also mentioned that if he hadn't known about the origins of this music, it would have scared him to no end. In 2008, NASA shared the transcripts of the Apollo 10 transmission, but according to the documents themselves, they were declassified in 1982. In 2012, NASA also shared the audio files online. If you listen to these files, you'll hear that the astronauts sound sincerely awed and puzzled by what they hear. Moreover, they bring it up over and over again. It's also worth mentioning that you never actually feel that the 3 men were panicked or alarmed while going over the transcript or the audio. Some sources put particular emphasis on the fact that the space music started when the astronauts were over the far side of the moon. They didn't have radio or visual contact with Mission Control for about an hour, something that had been expected. Some documentaries used this moment to create tension by saying things like, the astronauts were on their own, no one on Earth could see or hear them. However, the narrators never explained why the astronauts' isolation could have been such a significant factor. By no means was it connected to the not-so-mysterious sounds undersourced. There's another interesting element to this story that we should consider though, and it's the fact that Apollo 10 astronauts never discussed this incident and the sounds publicly. However, it's still unclear whether they talked about it with NASA engineers. This makes some people speculate that the astronauts didn't want to project anything but a rock-hard psyche. Showing a drop of confidence even once during the whole mission could have left them out of the whole project. Hi, my name is Martin. I am the author of this channel, and today I'll tell you all about the evidence of astronauts meeting with unidentified things at the time of observation. It's the year 1962, and American John Glenn is orbiting Earth in his Friendship 7 capsule on the Mercury Atlas 6 flight. He looks out of the window and sees fireflies.
Well, maybe those are not fireflies, but he clearly sees some weird bright specks clustered around the ship. Unsurprisingly, he tries to find a logical explanation. Can they be ice crystals from the spacecraft's hydrogen peroxide attitude control rockets? But Glenn is unable to correlate their appearance with the use of the rockets. The mystery remains unsolved.
Only much later will we find out what those fireflies were. You see, spaceships tend to accumulate clouds of debris and contamination around themselves. And when Glenn's rockets sprayed jets of crystals, many of these crystals accumulated in the cloud. They reflected sunlight and interacted with other gases, looking like tiny sparkles. The case of the mysterious fireflies is now officially solved.
But it isn't the darkest space tale. One of the most famous cases of seeing bizarre stuff in space comes from Apollo 11. That's when Neil Armstrong, Buzz Aldrin, and Michael Collins noticed a UFO pacing along with them during their flight to the moon. That's how the astronauts described this incident. We did watch a slow blinking light some substantial distance away from us. There was something out there, close enough to be observed. The period of uncertainty was rather brief. The astronauts and ground control soon identified the object. It was one of the 4 adapter panels that fit between the 3rd stage and the lunar module. These panels were ejected from the 3rd stage, and one of them continued along the same trajectory as the lunar module with the crew. While moving, it rotated and blinked when sunlight was reflected off its surface.
Another famous and truly creepy picture hinting at the presence of alien life on the moon was taken by the crew of Apollo 16.
As the astronauts were leaving our natural satellite, they made a video, and 4 seconds of it showed a near-perfect Hollywood flying saucer leaving behind a plasma trail. For more than 30 years, enthusiasts used this video to prove that aliens had paid us a visit.
But then, scientists decided to take the matter into their own hands. They realized that, when viewed from the window through which the video had been taken, the object in the film was actually consistent with a small floodlight sticking out from the side of the capsule on a boom.
Look, from this angle, the floodlight looks exactly like a flying saucer. And the boom, indeed, looks like that plasma trail. And do you see this? Those are a couple of bolts on the boom.
Another report that inspired UFO enthusiasts came from Gemini 7. Astronauts Frank Borman and Jim Lovell were making what was called a football maneuver. It was supposed to get them into a position where they would make recurring close approaches with their Titan II booster stage every orbit.
But when they were performing this maneuver, Barman reported bogey at 10 o'clock high. We have several, looks like debris, up here, actual sighting. We also have the booster in sight. Yeah, have very, very many. Look like hundreds of little particles banked on the left out about 3 to 4 miles. It looks like a path to the vehicle at 90 degrees. They are past now. They were in polar orbit. Lovell claimed that the booster was in sight too, slowly tumbling along with the debris cloud. Does it mean that Bogman's bogey particles couldn't have been the booster or booster debris? After all, they were moving in a different direction, traveling along a different trajectory. Well, not necessarily. Later analysis showed that those particles were ice flakes from leftover fuel from the Titan II.
As you see, astronauts often report seeing weird stuff out there, but NASA's reaction is often anticlimactic. Let's have a look at how they commented on the statements of an astronaut who claimed to have witnessed alien presence in space.
NASA doesn't track UFOs. NASA is not involved in any sort of cover-up of alien life on this planet or anywhere else in the universe.
We should also remember that unidentify doesn't necessarily mean positively identify as an alien spacecraft. There's a lot of objects in orbit, and a lot of stuff travels along every mission. So, we'll always have UFO reports as long as we have space programs.
If you've ever wondered about what a black hole consists of, you're in the right place at the right time. I bet you've heard of this first one, the event horizon, and it's exactly what makes a black hole. Well, black. We could probably think of the event horizon as the boundary of no return. Once you cross the event horizon, the velocity you need to escape the clutches of the black hole is already higher than the speed of light. So, whatever passes the event horizon, be it light or any object, is doomed to stay inside. And since light can't get out from behind the event horizon, black holes neither emit nor reflect it. Nothing about what happens to them can reach an outside observer. But wait, then how did we get these beautiful photos of black holes? The thing is, we observe not the black holes themselves, but the light emitted by the matter surrounding them and forming a structure called an accretion disk. That's the main light source of black holes. For example, look at this stellar mass black hole. It's paired with a star and is pulling gas from it. Supermassive black holes do the same, but they munch on stars that stray too close. Eventually, all this stolen gas settles into an insanely hot, bright, and rapidly spinning disk. Matter is working its way from the outer edges of the disk toward its inner sides. Once it reaches the edge, it falls into the event horizon. If you looked at an accretion disk from up close, you'd see that it has a rather funny shape when viewed from some angles. That's because the gravitational field of the black hole warps space-time, the very fabric of the universe, and light travels along curved lines. The clever word for this process is gravitational lensing. The light that comes from the top of the accretion disk behind the black hole seems to form a hump above it. You can notice it in this image, see? And the light from beneath the far side of the disk creates another hump below as it takes a different path. But the coolest thing, if you looked at the disk exactly face on, you wouldn't notice any humps whatsoever. Then we've got the event horizon shadow. This is a dark zone which is around twice as big as the black hole's actual surface. The shadow is created by the combination of two effects. First, the event horizon captures all the light passing through it, and second, the curved space-time around the event horizon causes light to be redirected through gravitational lensing. Let's move on to the next part of the black hole, and it's a photon sphere. Do you see these thin rings of light that appear at the edge of the black hole shadow? They're actually numerous, highly distorted images of the accretion disk. Here, light from the disk orbits the black hole multiple times before escaping. The closer to the black hole, the thinner and fainter the rings are. There's also another visual phenomenon known as Doppler beaming. From most angles, one side of the accretion disk always looks brighter than the other. That's because near the black hole, the disk spins so fast that light streaming from the part of it spinning toward us becomes bluer and brighter, while light from the side of the disk rotating away from us becomes redder and dimmer. Next, you've probably heard that our sun has something known as the corona. Well, the black hole has one too, and it's one of the most extreme environments in the universe. Some scientists claim that powerful magnetic fields threading the inner accretion disk extend out and create a turbulent billion-degree cloud. Particles in the corona hypothetically orbit the black hole at speeds approaching the speed of light. Some experts believe that the corona might be a source of ultra-high energy X-rays, but we still don't know much about them. Plus, these coronas themselves can appear and disappear, following some patterns only they are aware of, which makes them even more mysterious. And finally, according to the theory of general relativity, the center of the black hole contains a point where matter is crushed to infinite density. This point is the final destination of anything falling into the event horizon, and it's called singularity. At the moment, astronomers aren't sure whether it's a physical structure or a purely mathematical one.
Hey, ever wondered what's bigger than infinity? Infinity plus 1? Nope. It's not even infinity times infinity. But indeed, there are situations in which one infinity can be bigger than another infinity. I hope I haven't confused you yet. First of all, we've got set theory. That's when you take a group of something and put it into a defined set. For example, 5 pencils. But it can actually be anything. It doesn't matter. What matters is there is stuff in the set. Okay, you might be wondering, how can it help me understand infinity? Let's try to somehow define the size of the set. Well, it's easy to understand that the size of a set of finite elements is simply the number of these elements. But how should we think about the size of infinite sets? Oh, let me introduce correspondence to you. This is a concept in set theory that functions by relating one individual object in one set to another individual object in another set. These individual objects can be some items or just numbers. The main thing is that each item in one set can be compared to an item in another set. For example, 2 pencils to 2, 4 pencils to 4, and so on. We cannot compare the sizes of infinite sets, but we can define correspondence between elements. And if 2 given sets have a one-to-one correspondence between their elements, then these 2 sets have the same cardinality. Roughly speaking, the word cardinality means numbers of elements. If the cardinality of some infinite set is equal to the cardinality of the natural numbers 1, 2, 3, 4, 5, 6, we call the power of this set Aleph 0. Let's stop here for a moment and do some math. Do you still remember our main question? Right. How can one type of infinity be smaller than another? But what if we use 2 different sets of counting numbers, which are also called natural, and imagine that both these sets extend forever? Set A, 0, 1, 2, 3, 4, 5. Set B, 1, 2, 3, 4, 5, 6. As you see, set B starts one number higher than set A. But we have one-to-one correspondence between sets. It means that they represent equal types of infinities. In other words, each number in set A corresponds to another number in set B that is one value higher 0, 1, 1, 2, 2, 3, etc. Now this is the smallest type of infinity, the very Aleph null. Okay, another question remains. Why isn't infinity? Let it be Aleph null plus 1 bigger than good old Aleph null. Well, here's another example. This person is a cyclist. We take his bike, use it as a +1, and put it in set A. Now, our sets look like this. Set A, bike, 1, 2, 3, 4, 5. Set B, 1, 2, 3, 4, 5, 6. Following the logic, we match the bike to 1, 1 to 3, 3 to 4, and so on. As you see, it's possible to keep this one-to-one correspondence between the sets, and it can go on forever. It means that infinity and infinity plus 1 indeed have the same cardinality. But wait, it gets even weirder. Picture building a set using only natural numbers ending in 0, 10, 20, 30, etc. Then you compare it to the set with all the natural numbers 0, 1, 2, 3, 4, 5, etc. At first glance, it seems that the second set should be 10 times larger than the first one. But as far as the set theory is concerned, these 2 sets are equal. Amazing, isn't it? Then how can any infinity be bigger than another one? To figure it out, we need to enter the world of real numbers, which are any numbers representing a quantity along a continuous line. It can be 59, 4.335,081 pi, any fraction that comes to your mind, and so on. Imagine 2 points on a line. Between these very finite points, there's an uncountable and infinite set of numbers. Long story short, just trust us that mathematicians can prove that it's impossible to create a one-to-one correspondence between natural numbers and every possible real number. Here you go. With the help of sets, we've found an infinity which is bigger than the infinity Aleph null.
Our home Milky Way galaxy has 2 very well-known satellite galaxies, the Large and Small Magellanic Clouds. They were named after Ferdinand Magellan, an explorer who led the first circumnavigation of the globe a whopping 500 years ago. During this expedition, 2 groups of clouds were discovered in the southern night sky. Those are now known as the Magellanic Clouds. But they're not the only ones. The Milky Way is surrounded by at least 61 other galaxies within 1.4 million light-years. For comparison, our neighbor, the Andromeda Galaxy, is 2.5 million light-years away from us. And still, astronomers think there are many more satellite galaxies, perhaps even too many. But first, let's figure out what a satellite galaxy is. Our Sun is just one of a truly huge collection of stars in the Milky Way. Hundreds of billions of stars orbit the center of our galaxy. But something much bigger orbits the Milky Way's center too: other galaxies. They are way less massive but have their own stars. We can compare the Milky Way to our Sun, and those other galaxies to planets. Astronomers call such formations satellite galaxies. The Milky Way's biggest satellite galaxy is the Large Magellanic Cloud. It's located about 163,000 light-years away and is about 1/100th the size of our home galaxy. Unlike the spiral Milky Way, the Large Magellanic Cloud doesn't have a clean spiral shape. One theory claims that it's because the Milky Way and other galaxies pull and warp it. In terms of distance, there are 2 candidates that can fight for the title of the closest satellite galaxy. One of them is so small that scientists consider it a dwarf galaxy. The other is so close that it's still debated whether it's a separate dwarf galaxy or part of our own galaxy. The satellite galaxy everyone agrees on is the Sagittarius Dwarf Spheroidal Galaxy. It's around 50,000 light-years away from the center of the Milky Way. But there's a cluster of stars that is even closer than that. Some experts call it the Canis Major Dwarf Galaxy. It's likely to contain about 1 billion stars and is located so close to the edge of the Milky Way that it's actually closer to our solar system than to the galaxy's center. Some astronomers don't think the Canis Major is its own galaxy. They believe it's simply a dense area of faraway stars, which is still part of the Milky Way. Whatever the case is, this bunch of stars was once pulled toward the Milky Way by our galaxy's immense gravity. That's how most satellite galaxies in the area are likely to end up. Once, they might all merge into an even larger Milky Way galaxy. But let's get back to the assumption that the Milky Way has too many satellite galaxies. A team of astronomers has been hunting for such galaxies using the Subaru telescope. So far, they have searched a mere 3% of the sky. And still, they have found 9 previously undiscovered satellite galaxies. That's far more than they expected to spot. Interestingly, most of the satellite galaxies orbiting the Milky Way are newcomers. Yes, even the large and small Magellanic Clouds. This most recent research hopes to improve our understanding of our corner of the universe with the first detailed search for companion dwarf galaxies. However, the study also has another goal: to figure out dark matter distribution. You see, the current theory claims that the mass of our galaxy consists of 2 parts: visible matter, like stars and planets, and something invisible, which is hypothetical dark matter. We can't see it directly, but we can feel its gravitational influence through a certain distribution of mass in galaxies. Strangely, the simulation of the dynamics of the galaxy and this dark matter predicts hundreds of satellite galaxies in the Milky Way. Until recently, we only knew about a few of them, which created a contradiction known as the missing satellite problem. Hopefully, the new research will solve this problem. The team admits that so far their research has been based on statistically small numbers. Several assumptions have also been made based on a particular distribution of satellite galaxies. Follow-up studies of stars in the satellite galaxies and high-resolution imaging are definitely needed to progress further.